Hi, I'm Joe Calamari with Project Geospatial here at the GEOINT 2023 Symposium. And I'm at Synthetaic's booth with Corey Jaskolski. Sorry.
Nice to meet you.
So, Corey, could you tell us a little bit about yourself and how you got introduced to the industry?
You bet. Yeah, so my background is AI and ML, but I had kind of an eclectic career background. I did a lot of work developing edge-based AI and processors for government applications, and then ended up joining National Geographic, where I used AI and technology to do things in the geospatial world, like 3D scan Mount Everest to look for vegetation growth up the side with climate change, and also a lot of mapping and 3D scanning with AI for anti-poaching applications and things like that.
Awesome. How did that lead you over to Synthetaic?
So Synthetaic grew out of a lot of that work because AI actually fails more often than it succeeds. It's sort of the dirty secret in AI. Nobody wants you to know that, but it does. And the problem generally is data. It's the amount of labeled data that you need to train an AI. When you see an AI, maybe that if you pull out your cell phone and you try to focus on a cat or a dog and your phone automatically does that on an animal like a cat, it's because somebody trained an AI to do that by labeling many cat images. And that means they went and drew boxes around lots of pictures of cats until an AI learned to do that. And it sounds easy, but really, as AI models have gotten bigger and bigger, you're not looking at doing that on a couple images of cats, you're looking at millions or billions. So when a company like Google or Facebook trains an AI model, they're literally training on billions of labeled images. So the question became, how do you do that in a geospatial application? How do you find Russian tanks, or how do you find something even more rare, Chinese spy balloons, where nobody ever has seen an image of it from space, so you don't have any labeled data? So we started Synthetaic to answer the question, what if you didn't need labeled data? What if you could actually build an AI without pre-trained models, without labels, and find effectively anything? What might you be able to do?
Yeah. So you touched on this a little bit, but I love the phrase, what goes up will be found. So could you talk a little bit about like these recent use cases like that spy balloon that you guys found?
You bet. Yeah, a really good use case for Rake, our product, was the Chinese spy balloon. So when the Chinese spy balloon came across the United States, we started thinking, hey, could we actually find this in satellite data? And the problem is again, with AI, you normally train an AI model on labeled data. Since nobody had found a balloon in a satellite data before, we actually hand drew what we thought this balloon would look like in Planet satellite data. So we hand drew this balloon, and we fed in the entire state of South Carolina because we knew the balloon got shot down right off the coast. And we searched the Planet data with our algorithm across that data set, and we found the balloon in 2 minutes from our hand drawing. And from there, now that we had a real image of the balloon, Rake could adapt to that, and we actually traced it back through the United States, and then ultimately all the way back to its launch point in Hainan with, I think, a total of 12 hits along its entire journey.
Ah, that's amazing. Now, is this Rake that you have up here?
This is, yeah. So, all right, so this is Rake, and what Rake does is you give it a single example, whether it's a hand drawing of the Chinese balloon, or in this case, I drew a box around this full dumpster in Milwaukee. And so I drew this box around it. I don't have a pre-trained model. I didn't have labeled data. And what it did is it searched across all of Milwaukee, all of these million or so map tiles, for other things that look like this. And what it returns is a similarity map. And this actually works in a way that's sort of similar to ChatGPT. ChatGPT doesn't know what English language is or what the words are. It maps it into a mathematical space, and then when you ask it a question, it knows how to put the words together in a response. We're doing something sort of similar to that in Pixospace, but our response from our query was that image of a dumpster. Our response is other things that look similar throughout Milwaukee. So what Rake has done already is found these full dumpsters throughout Milwaukee. And what we can do, it's a human-machine collaboration. So we can actually take our little polygon tool here. We can draw a box around the things that we say, yep, Rake, you did a good job. Those are all dumpsters. That's not a dumpster. This is a pickup truck with stuff in the back of it. You can see why Rake might think that's a dumpster, but it's not. So we can nudge Rake by saying, these are the things that I want you to really focus on. These are legitimate dumpsters. And then Rake will take that feedback from us, and it will refine itself and continue to learn over time. So in this case, though, we already located the dumpsters throughout Milwaukee, and we can drill in here and find dumpsters in people's backyards that are maybe doing home construction, and other scenarios here where we can actually find something like that. So here's a dumpster in a yard that we found from our original query. So we can take this across commercial data or defense and intelligence data and literally search at scale across, in this case, the city of Milwaukee, but in other cases, the entire globe or the country of China, for example, and find all of the objects we're looking for.
Well, that was great. Thank you. So we're over here in the kind of AI neighborhood of the symposium right now. So could you tell us a little bit about what differentiates you guys from everybody else in this block?
Yeah, our differentiator is really the ability to build an AI model in seconds without any labeled data or pre-trained models. So we consider it effectively a really, really fast, simple search tool that can also then build an AI in just a few minutes. And so the differentiation there is that without the need for that labeled data, you basically can eliminate that whole, sometimes thousands of people labeling data over months before you can even have an AI to start with. We can develop these answers in tactical timeframes and let people derive answers just in a few seconds. The other thing that really differentiates us, though, is once we've ingested data into Rake, normally when you run an AI, you've built an AI to find that one thing. You run it, and now you say, ooh, I also want to find fighter jets. You need to build a new AI. You need to run it again across the data. With Rake, you actually, once you've ingested into Rake, you can search for anything you want forevermore, even if it's something you didn't think you wanted to find when you already ingested the data set. So,
wow, that's great. So as we're wrapping up now here, do you have any final words about what you would like these people to know about Synthetaic?
Yeah, I think what we'd like people to know about Synthetaic is now there's a new tool available that allows you to build an AI to find things in data sets that doesn't require pre-labeled data and millions of dollars of labeling work, but it also doesn't require a big data science or AI team. We certainly have lots of customers that have big data science and AI teams that are using it. But even if you're a smaller company that is just looking to drive insights from data immediately, Rake can do that.
Awesome. So where can they find you? Reach out for some more info.
You can reach out on Synthetaic.com. Synthetaic is spelled funny. It's an AI instead of the I in Synthetaic. So you can reach out to us at Synthetaic.com and learn a lot more about what we're doing.
Great. Thanks, Corey.
Awesome. Thanks a lot.
I'm Joe, Project Geospatial. See you next time.